All right, I want to go back to where we were at yesterday to finish off this problem. If you were not here yesterday, make sure you're watching the videos. This right here, we had a 1-6 for basically every single one of these, and we were just determining if this game was fair or not. What was the other one? $2. Then you get $3. And when we did this, we calculated that that was -1/2. They calculated 0, and I did it twice. All right, so thus, in the long run, a player will what? Is this a favor for the player or the club? For negative? Oh, that's right. We'll be losing $0.50. Yes. So the player will lose money. And the game, is it fair or not fair? Is not fair. How do I know if it's fair? Nope. If it's 0, right? So even if you get a positive number, it's good for you, but still not a fair game. Right? Just want to recap that. Any questions there? I think we had one more example, and then we'll get into 5-3, which is the last topic for this week. My plan is to have a homework day tomorrow, which we don't get many of, mainly because I think I'm going to lose half of y'all anyways for y'all's district meet in Anderson Shiro. So I think that works out pretty good. All right, so this one's an insurance company insures a person's antique coin collection worth $20,000 for an annual premium of $300 if the company figures that the probability of the collection being stolen is 0.002. Find the company's expected profit. Construct a table showing gains or losses and the probability of each to determine the expected value. All right. You weren't given a table, but basically what we can do here is you have a probability that it will be stolen, right? So if stolen, basically they have to pay you $20,000, but you had to pay them $300. Right? And for this to happen, that would happen in a probability. So probability of 0.002. Right? The alternative to this is they gain $300 if it doesn't get stolen, and that probability is 0.998 when we subtract it from 1. Right? So to figure out if this is a good for the insurer or good for the company, then you just work it out. What's negative 20,000 plus 300? Very good. We'll take that, multiply it by 0.02. So if they lose, they'll lose 19,700. But if they gain, if they don't, basically, if they don't lose the product, it doesn't get stolen, they'll gain $300. And that will happen 99.8% of the time, or at least that's what they're predicting. So then we just figure this out. So let's get our handy dandy calculator, because I don't assume y'all know this one. 19,700 times 0.002. So that'd be -39. You were close. Just you had eventually moved all your zeros. So you get -39.4. So they're predicting that they'll lose about $40 on average there. And then to gain, they're predicting 300 times 0.998 that they'll gain $299.4. Probability statistics there. And then we'll just subtract the 2. So their outcome states that they will gain $260 in this odds. So that's their expected value. Every month, or I guess this is a monthly premium or annual? Annually, so every year they think they can gain $260 from every customer that does this. So is it worth insuring these people? For the insurer, it is. For the person trying to get the insurance, he's going to lose money over time. That 20,000 is just dwindling away over time, right? There you go. So any questions on finding out if the probability of an event happening and expected mean, probability mean, basically. Right? So no more dividing. We're just multiplying the probability to the events are happening. All right, so let's talk about binomial distribution. We talked so much about unimodal, which is just a bell curve, that we don't really talk too much about binomial distribution. Binomial just meaning there's two little humps. So what we're going to do is we're going to find the exact probability of success in trials of a binomial experiment. Typically about 90% of the time, it'll tell you if it's unimodal or bimodal or bell curve or bell shape. So you can kind of figure out which formulas you would use. I will say for my test's sake, it's easier because obviously the test will be over 5 and 6. So you'll know exactly what you'll be dealing with. When we get to the final is what will get harder. You might not remember which formulas to use. It will usually tell you, hey, this is unimodal, this is bimodal. Then you have to remember, I use these formulas for this situation, use these formulas for this situation. So that's when statistics gets hard, is now in the test mode. It's easy because it's like, obviously I'm being tested over this. I know what to do. When you do the overall test, it's remembering, all right, what's that for bimodal? What's that for unimodal? Is this for multimodal? Is this for, well, you'll learn about t-tests and all that good old stuff. And what's the Chai's theorem and all those great things later on. So that's where statistics will get a little hard. All right, but hopefully you'll be successful in all the regular tests where final won't be too big of a deal. Regardless of my rant, some variables can have only two outcomes, or the outcomes can be classified in exactly two categories. For example, when a coin is tossed, it will land on either heads or tails. In addition, a multiple choice question with 5 options will have one correct choice, and the other 4 choices will be incorrect. Thus, the answer choices can be classified as either correct or incorrect. You have 2 options. You can also think of this as coding, right? Is it bycoding code? Where you have the zeros and ones, binary. So kind of same concept. There's just 2 options, it's either on or it's off in that computer program. All right, so let's fill in some blanks here. Or was there a blank to begin with? Okay. All right, so here we go. So these situations are called binomial experiments, what the title states. So each repetition of the experiment is called a trial. So every time you flip a coin is a trial, and that gives you another trial. So in a binomial experiment, I don't either, just to give you something to do, I guess. So is a probability experiment that satisfies the following 4 requirements. There must be a fixed number of trials. So there must be 10 trials, 20 trials, not infinite, must have a set number. Each trial can only have 2 outcomes, right? So being correct or incorrect, true, false, flipping a coin, heads, tails, male, female. It does have to be 50-50. Only 2 options can be selected for each trial. So if you have like, I don't know, dice or a die, right? That has 6 options. Now, it can become a bimodal if your odds are, what's the probability of being 1? So it's either a 1, yes, or not 1. So I guess in that situation, it's no longer 50-50 because then that could be 1-6 and 5-6. I like that. You're right. It doesn't have to be 50-50 because you take a 5 multiple choice question, you have 20% chance of getting it right, 80% getting wrong. I take that back. It's not going to be 50-50, but you can only get either or. I see what you're going with that. That's 50-50, depending on the population. I like the way you think. That's good. So yes, they won't be 50-50, but you only have 2 options, either this or this. Now the odds of that will go up or down. So each trial can only have 2 outcomes or outcomes that can be reduced to 2 categories. So that's what I was saying. The die, it might have 6 options, but if you reduce it down to I'm getting a 1 or I'm not getting a 1, there's your 2 options. So you have a 1-6 or a 5-6.